In a way, the web is in the middle of a constant two-front war, and you're on the front lines every single day, whether you realize it or not. So today, we're going to pull back the curtain on two of the biggest threats out there, SQL injection and cross-site scripting. We'll break down exactly how they work, why they're such a big deal, and how the good guys fight back, all in plain English. Let's dive in.
Seriously, just think about that for a second. What if you could see the digital world with a kind of X-ray vision? What if you could understand exactly where an intruder might try to sneak past the defenses of the sites you use for shopping, banking, and just about everything else? Well, that's the perspective we're aiming for today.
All right, we're starting with our first front in this war, SQL injection. The best way to think about this one is as a direct assault on the fortress. The backend database that holds all the treasure, all the valuable information a website needs to even function. At its most basic level, it's really all about a conversation. A web app has to talk to its database, right? And it does that using a language called SQL. Well, an SQL injection, or SQLI for short, is basically when an attacker cleverly slips their own sneaky commands into that conversation, tricking the database into doing things it was never, ever supposed to do. And this right here, this is the absolute #1 golden rule of web defense. Every single time you type something into a search bar, a login box, whatever, that's user input. The fundamental mistake that vulnerable sites make is just blindly trusting it. The secure way to think? Assume everything a user types could be a hidden command in disguise. Okay, so how does an attack like this actually go down? Well, it's a shockingly simple but totally devastating three-step process. First, the attacker shoves their malicious code into a totally normal-looking form. Second, and this is the key, this is where everything goes wrong, the application completely fails to sanitize that input. It doesn't clean out the dangerous bits. Finally, that malicious command gets passed right along to the database, which just runs it, no questions asked. And if that command slips past the guards, man, the consequences are just huge. An attacker can just waltz right past the login screen, no password needed. They can start yanking out sensitive data. We're talking customer lists, personal info, maybe even credit card numbers. They can mess with data, delete it entirely, or in the absolute worst case scenario, take complete control of the whole server. And this quote, it really hits the nail on the head, doesn't it? The damage isn't just about code and data. It's about something way more fragile, trust. A single successful attack can completely shatter a company's reputation, and once that's gone, it is incredibly hard to get back. Now, attackers are pretty clever, and they have a couple of main tricks up their sleeve for this. With a union-based attack, they kind of piggyback on a legitimate request, tricking the database into tacking their malicious results onto the real ones. But the error-based one? Oh, that's just as sneaky. The attacker intentionally tries to break things, just so they can read the error messages that pop up, because those messages often leak juicy clues about how the whole system is built. Okay, so we've stormed the fortress. Let's pivot now to our second front. We're moving from attacking the database to hijacking the messenger. This is cross-site scripting, or XSS, and this is an attack that comes directly after you, the user. So the big idea here is totally different. Instead of going after the server's database, the attacker's main goal is to get their malicious code running inside your web browser. They basically turn a website you trust into a delivery system for their attack. The website itself becomes the weapon. So, what does a weak spot even look like? Well, here's a super simple classic test. Imagine you could type a little piece of script into a comment box, and instead of just showing up as text, a little pop-up box appears on your screen. If that happens, whoa. That's a huge flashing red flag. It means the site isn't filtering things properly, and it's probably vulnerable. And not all XSS attacks are created equal. They actually come in a few different flavors. First up, you've got stored XSS. That's where the malicious script gets saved on the server, maybe in a forum post. It's like a digital landmine just sitting there, waiting for anyone to visit the page. Then there's reflected XSS. Here, the attack is hidden inside a shady link, and the website just reflects the attack back at whoever clicks it. And finally, you have DOM-based XSS. And this one is the sneakiest of all, because the weakness isn't even on the server, it's in the code already running in your browser. And the damage here, it gets really personal. A lot of the time, attackers are hunting for your cookies, those little digital breadcrumbs that keep you logged into a site. If they can snatch that, they can hijack your entire session and basically become you online. From there, they can mess with the site,
send you to phishing pages, or even capture every single thing you type. Okay, so we've got these two major threats, one attacking the fortress, the other hijacking the messenger. But let's get real. How big of a deal are these attacks in the actual real world? Let's talk about the fallout. Look, these aren't some obscure, once-in-a-blue-moon kind of problem. There's this super important group called OWASP, and they put out a top 10 list of the most critical security risks on the web. And guess what? For years, injection attacks have been sitting right at the top, very often at number 1. And XSS, it's been a fixture on that list for a long, long time. These things are everywhere.
And you see this play out in the headlines, right? It only takes one tiny flaw, a single forgotten login form, to blow the doors wide open and expose thousands, maybe even millions of customer records. A single point of failure like this can be absolutely devastating for a company. All right, so how on earth do you fight a war on two fronts like this? Well, it's not about looking for one magic solution, a single silver bullet. The whole strategy is about building a smart, layered defense. And the philosophy behind this is something called defense in depth. Just think about a medieval castle, right? They didn't just build one big wall and call it a day. No way. They had a moat, a drawbridge, high walls, and sentries. Each layer provides more protection, so if one fails, there's another one right behind it to stop the attack. You just can't rely on one single thing. In this defense really has two different ways of thinking. You've got the proactive defense. That's like an architect checking the blueprints for weaknesses before the castle is even built. Then you have reactive defense. That's like the guards at the gate, checking everyone who tries to get in, right now, in real time. And you absolutely need both. So what's actually in this defensive toolkit? Well, first, you've got static code scanners. Think of them as your spies, finding flaws in the code before the battle even starts. Then you have your web application firewalls, or WAFs for short. These are your gatekeepers, inspecting traffic and blocking anything that looks malicious. And finally, you have intrusion detection systems, or IDS. These are the sentries on the wall, watching for known attack patterns and sounding the alarm. Okay, we have covered a ton of ground in this two-front war, so let's boil it all down. If you walk away with just one key takeaway, what should it be? If you remember just one thing from all this, let it be this. SQL injection. It's an attack on the database. The goal? Steal server data. The cause? Trusting bad input. On the flip side, cross-site scripting. It's an attack on the user's browser. The goal? Hijack their session. The cause? Sending back unfiltered output. See the difference? Input versus output. That's the whole game. So we'll leave you with this idea. Every single time you search for something, log into an account, or post a comment, you're part of this invisible battle. It's a constant, hidden war being fought for your data. And it makes you wonder, right? What does this all mean for the websites you trust every single day?